So let's just go ahead and start off with your background.
Yeah, so I for 10 years I was a professor at Yale, and then I was very lucky to become the chief scientist at Robust Intelligence. And then Robust Intelligence was acquired by Cisco, and now I'm a senior director of AI research at Cisco.
Awesome. Maybe tell us a little bit about your experience at EPFL.
Very good. Okay, so you're going back many years ago. So yeah, EPFL, very, very good memories. I did almost all my studies at EPFL in first electrical engineering and then computer science. Um, I finished end of 20, I think end of 2012. Then I was very lucky uh, to have a postdoc with Andreas Krause at ETH for almost a year and a half, 2 years, and then I joined Yale.
Sure. Awesome. Tell us a little bit about your experience at Yale.
Good. So I was part of basically at the time Network Science Institute, which was run by Dan Spielman and Nicholas Christakis. So that was my home basically for many many years, and then after um, I think 8 years, we converted almost that institute into the Data Science Institute, and I was a member of that institute for about 2 years before moving all the way to the West Coast.
Yeah. So what brought you to the West Coast?
It was mainly robust intelligence. I was fortunate enough to know the CEO, Yaron Singer, who was a very old friend, and we have been always in contact with one another for many years. So a few years back, he started robust intelligence. He was also a professor at Harvard. He moved from Harvard to the West Coast, started a company, and then in one of these discussions, we it was very serendipity. He was like, okay, why don't you come become our chief scientist? We are doing great. There's a lot of interesting stuff you're doing, and take a leave. And I'm happy that I took a leave, and then that became a permanent leave.
Yeah.
So yeah, in that regard, I'm very lucky and super grateful to um, the friendship and robust intelligence and all the things that we did together.
Awesome. So I think maybe some people in the audience don't know what robust intelligence is. Do you want to maybe just tell us a little bit about the problem the company solved?
Yes. So at robust intelligence, we were doing multiple things, mainly on evaluating the machine learning models, and they started before generative AI, so it was all pre generative AI, where stress testing the models were mostly about adversarial examples in images and those kind of things. Of course, generative AI happened, and that is exactly the time that I joined Robust Intelligence, because like there was a shift of focus on the next technology. So and there were a lot of emphasis on jailbreaking large language models, and with the first thing that we did at Robust Intelligence was basically coming up with one of the first and most effective automated jailbreaking methods without any human in the loop.
Mm-hmm.
So that was part of what robust intelligence did. And the complement was what we called AI firewall. So if you are a frontier lab, or if you are developing an LLM, and we stress test that LLM for you in many 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 directions, and give you like all the problems that might occur deployment of your large language models, then the next immediate question is how to prevent. And for that, we also provided what we called an AR firewall solution, which sits around the model and tries to flag any suspicious activity.
Cool. So maybe just tell us a little bit about, so you mentioned sort of how you got introduced to robust intelligence. Before that, you were a professor at Yale, and then you sort of made this decision to leave. So maybe just tell us a little bit about the difference of, being in academia versus being in industry at this, really fast growing startup.
Yes. I think they both have like, amazing setups, right? At the university, I think yeah, my job was basically, it was on the foundation of AI and, how, what is, trying to understand deeply what is happening with this new technology. And I have been working um, on both sides of how to, what, how these models generalize, how we can make them generalize better through better optimization. And also have been working on, uh, the other aspect, how these models can be attacked. Okay. And what are the fundamental limits of defenses against those attacks? And it was mainly, for me, it was at the time, it was mainly like a very deep theoretical understanding of these models. Of course, the models are super complicated now. And the models that we had back then, they were super simple. I don't think that they really represented what is happening. And that was part of the dissatisfaction that I had about like what we study seems to be very different from what is happening.
Mm-hmm.
Um, and um, and then when the robust intelligence opportunity came out, it was like, oh, okay, I can actually cross the bridge and be in the grind of building, protecting, jailbreaking models. I can be part of that journey and be extremely practical. So they provide, I think, different setups for academics, and it can be, one might be suited for one person, another might be suited for another person, and then they might be suited for different stages of the career. I think I was very lucky that I had 10 years of like very deep understanding of like trying to deeply understand these models, and now I'm very excited about being part of building and securing these models.
Gotcha. All right, great. So without further ado, maybe we can get into some of your papers. Recently, I think in Europe's 2024, you had a paper titled "Tree of Attacks: Jailbreaking Black Box LLMs Automatically." This sort of goes in theme with some of the things that we've talked about before. Want to maybe just tell us a little bit about this paper?
Yeah, so this paper, I think it was quite influential. It got featured in Wired, and it was um, so it was one of the first methods that had a couple of nice properties. The first was that it the main purpose of this tree of attack method was to jailbreak closed source models. The models that you do not even have access to the model weight, to logics. You only see the input and output of the model. So that was very different from previous methods that they relied um, on calculating the loss and taking the gradient and so on and so forth. Here you don't have any of those information, and it seemed like a very hopeless problem. So that was one a nice feature about it. The other nice feature was that there is no human in the loop. So this method works automatically. You hook up this attack with the target model, and then it tries to jailbreak the model. And the third thing was that the success rate was better than any other model, any other attacking method. And the success for um, frontier models were on the north of 80% and 90% on almost all jailbreaking benchmarks. So, and that seemed very alarming also for model providers, right? That they spend a huge amount of money and effort in aligning the model through RLHF and its variants. And suddenly there is a very simple method that with $5 you can jailbreak, right? So the API cost was, you know, single digit. And so that was like, I think that is why it took, attention of many companies. And also it became, I think, one of the main methods that even today is part of the um, if you have a many of attack, it is certainly one of those attacks that you try.
Gotcha. Definitely makes sense. You've also
Yeah.
had, a few other papers that you've worked on in kind of similar areas. I think, you had a paper titled, Lazier Than Lazy Greedy, which is probably on a slightly different thing.
Yes.
This was back in 2015, so way back. Want to maybe just tell us a little bit about this?
Of course. So, um, you know, part of machine learning, or one of the main part of machine learning is how to select the data points, right? So um, if you have a data set, it, and is it, do you want to use all the data points in order to train your model, or do you want to use the most informative and representative data points in order to train a model? So that is a question that we have always had, from running regression to running LLMs. So this is called the subset selection problem in machine learning. And usually the problem is that you have so much data you cannot handle. So what people usually do is that they randomly sample data, um, to the capacity of how much they can handle, and then they train on that. So there is always a baseline, and the lazier than lazy greedy was a very, very, very simple method that tried to select representative data points from a data set. And it did it in a very lazy manner, meaning that what it did was, it was the first linear time algorithm that could go over the data set and pick data points. All the previous algorithms that existed in this domain, they were all, not, they were super linear. And, the most famous algorithm in this area was actually quadratic in the size of the data points that you wanted to select.
Gotcha. I think recently you also had another paper titled Large Language Models in Code Semantics in Low Dimensional Linear Subspaces.
Yes.
So this is just a much more recent paper, so maybe you can tell us a
Yes.
little bit about this one.
Yeah, this is something that it goes actually to how we defend large language models. So the idea of safeguarding large language models. And what we have observed, and in when we were working with large language models, actually we now train large language models for security purposes specifically. Um, what we observed was that, if you look at the malicious prompt and non-malicious prompt, okay, the prompt that are very, very, very malicious, it is clear they are malicious, and the prompts that are completely benign, you see that they're separated by a linear subspace. Okay, and that is the first observation. If you look at the activation, of one of the middle layers, and you train a linear classifier, you see that these data points, the embedding of malicious prompts and non-malicious prompts, are separated by a linear subspace. Jailbreak happens. So the prompts that try to jailbreak an LLM, what is very interesting about them is that they're actually at the boundary of this hyperplane. And that is why the models usually get confused. because if there is a prompt that is at the boundary and you just change it a little bit before the model was refusing it, after it's not going to refuse it. Okay, so that is how the idea came about. And then we also realize that it is not only about malicious prompts and non-malicious prompts. If you look at semantics like physics and mathematics and poetry, and you look at how large language models embed those things, what is really happening is that if you look at again the activation layer and the embedding of those text in this higher dimensional space, they're all separated by a linear subspace. And not only that, there are almost all these prompts that belong to physics, they happen to be embedded in a low dimensional linear subspace.
Gotcha. All right. So moving on, you are now at Cisco, after Robust
Yes,
Intelligence was
yes,
acquired. And I think now you're sort of part of Cisco Foundation AI. Maybe just tell
yes.
us a little bit about Foundation AI for the audience who might not be sure about that specific area.
Yeah. So, after we got acquired by Cisco, we were mandated um, um, to basically work on on the frontier of AI. Okay, and that is why we have the Foundation AI group now, which is around 40 people and 35, 40 people. And our mandate is to bring AI technology into Cisco. And, Cisco by definition, because it provides a, you know, Cisco switches, they provide 80% of the traffic, the internet traffic in the world. By definition, it becomes a security company because almost all the information go through Cisco product. So what we are trying to do is to be the leader in AI security. So provide AI capabilities for security applications that are going to be very useful for security companies and in particular for Cisco. And what we are currently trying to do is to develop open source models for the community so that if there is a SOC analyst, if there is, that work on security issues, they can use our models to better protect their entities, to automate all the hard work that they have to do so that they can actually work on the very specific and important problems they need to spend their time on. So that is our mandate, and that is the goal that we're pursuing. We open sourced, one of the best base LLM models. So that was like an LLM that is not post trained.
Mm-hmm.
About 3 months ago, it has already been downloaded maybe 200,000 times from Hugging Face. So there is a huge demand from the security professionals on using LLMs. We recently open sourced, our IFT model, which is, um, on some of the security benchmarks, it is basically the frontier model in its league. And again, a lot of interest in using these small LLMs, 8 billion LLMs into production of security companies. And our next goal is to open source our reasoning model. And we're working very hard to open source the security for the first security reasoning model in this space. So this is what we're doing um, at Foundation AI. There are also other efforts like protecting Hugging Face. So we have a lot of efforts um, on how we can detect malware or models that are on Hugging Face and they can be they're not sanitized. They might actually have if you download from Hugging Face and serialize your model, it's going to, your system is going to be under attack. So this is an effort we call AI supply chain. There is now a partnership between Foundation AI and Hugging Face on that, and we basically flag the models that we think that are suspicious.
Awesome. So, it seems like you spent a lot of your time sort of focused on AI security, both at Robust Intelligence and now at Cisco Foundation AI, and maybe even to some extent before while you were at Yale and maybe some of your time at Google. And so, within, robustness and within sort of AI security, there's a lot of different areas. I mean, within LLM security, there's, jailbreaking like we've talked about, but there's also like model extraction, training data extraction, prompt injection. Within model security, there's like model watermarking, hardware security, so on and so forth. What would you say are some of like the key areas that like we need to work on, sort of as researchers or engineers, most today? Like, what do you think are sort of the key areas within AI security today?
All the things that you're saying are actually super important, and I have to say that maybe I should have said this disclaimer in the beginning of our conversation. Everything that I say, you should take it with a boulder of salt, not even a grain of salt, right? So this is a very fast evolving area, uh, and anything that I am trying to say is really my personal understanding of what is happening. So take it with a lot of caution. Um, so what I see as some of the most important areas is that we are getting very, very good at attacking models. We are we are extremely behind in defending models, and that is, I think, actually it is something that needs a lot of research from both academia and industry. It is something that is very fundamental. I feel that we are like in the beginning of the cryptography. Cryptography as a field, it went through this phase of things being very heuristic until they became not very heuristic. Right, the foundation was built, and then now we have cryptographic systems based on those foundations. We are at that phase. We're in the beginning where everything is extremely heuristic. You have an attack, someone comes with a defense, and for that defense someone else comes with a new attack, and this is to me that is a huge area of concern. To make things even worse, we are not anymore talking about a single model. We are talking about agentic systems. We're talking about systems that can execute. It's one thing that you jailbreak a model and basically extract information. It's a completely different thing when you jailbreak a model and then it executes on your behalf something extremely malicious. And there are examples of those things now. So so we're moving away from a single model to multi-agent, and again, attacking those multi-agent systems is much easier than defending them. So that is, I think, something we need real effort in research.
Cool. All right. So our last question here. You've worked on sort of the area for a while, but you've also been a professor and you've advised a lot of students. What do you think is sort of your advice to researchers, maybe people that are in school, undergrads, considering whether they want to get a PhD students that are trying to become professors or trying to think through different areas, or maybe even people in industry. Any sort of like high level guidance about how to come up with good research directions in different fields.
Yes, yeah, I've been very lucky to be in both, in both domains, and there is a little bit of resistance from both parties. I think, like uh, I think being a professor and having a lot of freedom in what you can do is a great thing, and we should preserve that because a lot of breakthroughs, almost all breakthroughs, even in AI, came from academia. So that is why there is an appeal to become a professor. In industry, really the resources are in industry, and the academia is very resource constrained. The industry, many industry, frontier labs, they have a lot of computing power, which means that they can actually do a lot of experiments that academics cannot do. That gives them a leg up, and that gives them, if they're basically building a microscope, and the microscope is in industry, and a much smaller version of it, happens to be in academia. So from that perspective, working in industry is more interesting, right? But it comes with a lot of constraints because you're working on a particular product, and you have to accept those constraints. Um, so I think literally two different modes of operation, and I think we are very lucky to be in the situation that both options are very interesting. I think we're at the moment in computer science and in AI in particular that any of these two options you take, I think people will be happy. And it's not like I don't know 30 years ago where being a professor was like the most amazing job. I think some of the industry jobs are as amazing now, and for some people actually much more suited.
Gotcha. Awesome. Well, thank you so much for your time. Thanks for coming on the podcast.
Of course, thank you very much for having me.